So hello and welcome to this video. Last time we set up a minimal OPC UA server with the Open62541 library, but the server was empty. The server didn't have any process data inside, and how to fill in process data in OPC UA server is the topic for today. But before we start filling in the data, I want to show you one important concept of how to fill in data in OPC UA server and what the address structure is about, or how the memory is organized in OPC UA server. So to show you this, I have pulled up the site from the company Unified Automation, because they have a quite good documentation about the base concepts of OPC UA server. And here I find some really good pictures I want to show you. So at first you have to know the memory of an OPC UA server, or the available memory in the OPC UA server is called the namespace or the address space of the OPC UA server. And inside the namespace you have you can put in objects, and this picture shows how an object is or how an object look like. So it's very similar to programming languages. An object can have some variables and some methods. Of course, you can read and write the variables and call the methods, but the variables can create notification. For example, if some data inside the variable changed, they will create a notification, and the methods can create some notifications too, if an event occurs, for example. And another important thing is an object can have references to other objects, and with these references you can build a tree-like structure. So you can say, well, I have a mounting point, and on this mounting point I hang on all the other objects, and so I create a tree-based structure. And the smallest addressable piece in the address space is called the node. A node can have some attributes. For example, if the node is a variable, it will have an attribute called data, in which the data of the variable is stored. And a node can have references to other nodes, and you can define the relationship to other nodes with the references. And so in every OPC UA server you have a root node, and all the other nodes hang on the root node in a tree-based structure. And that's important to know, because that's how we can fill data in the OPC UA server. So what we are going to do today is we will create this structure. I will create a new namespace called room 1. In this room we have a temperature sensor, and this is an object which contains 3 variables. One variable is the vendor name, so the vendor name of the temperature sensor, the serial number of the temperature sensor, and the current measured temperature of the sensor. So this is the data I will fill in to my OPC UA server. So let's open the OPC UA server. Source file. Okay, here it is. And the first thing we will do is add a new namespace to the server. Okay, for adding a new namespace I can use the function UA server add namespace, and the function needs the server at which the new object should be created, as the new namespace should be created, and a string which identifies the namespace. and I will call this new namespace room1. This function UA Server add namespace has a return value, which is an integer value. So I will create, so I will store it in a variable called ns namespace room1. And by default you have one namespace in OPC UA Server, and so when I add this namespace it should be the second namespace, but let's print the value of the variable. New namespace added with number 1. Okay. And now the next thing we will do is add a object, a new object called temperature sensor. Okay. And now I will show you the documentation of the Open62541 project. I have downloaded the PDF here. And here are some available tutorials. And inside this tutorial, working with objects and object types, here you can find an example how to define an object and how to add some variables to the object. So what I will do now is I will copy this code and modify it in the way we need it. So here we have the code from the tutorial, and let's change this node ID to room1 temp sense ID. So in this variable we will store the node ID of the temperature sensor, and as I already have mentioned, every node has objects, has an attribute field, and this attribute field we will set to UA object attributes default. So this node will be the node of an object. We don't need this line, so I will delete it. Okay, and now I will search for this function in the documentation to explain to you how this function works. And add object node. Okay, and here we can see the declaration of the function UA Server add object node. So the first argument we need is the server at which we want to add the node, the object's node. Then the second is the node ID we want to assign to this node. We can assign a numeric node ID. This is a number, or a string node ID, which is a string, or we can set this to, like we do in the example, to UA node ID null, and if we set it to UA node ID null, the function will pick up the next available node ID for the node. Okay. Here we can assign a parent node ID, so the node ID of a parent. We will need this to add the variables. This argument, a reference type ID. Here we have a qualified name. This will be a, so here we can set in a string which is a little explanation about what this node is about. Here we could add some type definition. Here we need to insert the attributes of the node. Node context. I have to 0. No context will be set to null. And this last thing is, if we set the requested new node ID to null, we can save the node ID into this field. Okay, so that's it. Here we add the objects node to our server. The server can use a random node ID. The qualified name, I will change it to, and we want it to be assigned to the second namespace, and I will change this to temperature sensor. So these are the attributes we want to set. The object attributes default. Here this we set to null, and here we want to insert the one temp sense ID. Okay, so with this command we add a new node to the server. So this was the object. Now we can assign the variables. Vendor name to server. And here in the documentation, this is now the PDF of the documentation. There is even an example how to create a variable. So what I will do now is I will copy this into my server source code. So I will call this vendor name attribute. This is the attribute of the node. Here we can set the vendor name. Yeah, let's make temperature or sensor king limited, for example. With this function, I've said if a node is a variable, it has a field value which contains the value of the node, and here we will set it to the field vendor name. Okay, we don't need this. Okay, so we want to assign this variable node to our server, and here it should pick a random node ID. Then our parent object should be, our parent node should be this node. So I will paste this in here. So we want to assign it to the second namespace, and the qualified name should be vendor ID, vendor name, and I have to change the attributes as well. So that's it, but I want to change one more thing, because sometimes it is more easier to add string node IDs, because on the client side it's easier to call string node IDs than numeric node IDs. So I will change this to string node ID string So we want this node to be in the second namespace, and we want to assert the name room1 temp sensor 1 vendor name, and let's change it up here too. Temperature sensor. Okay. And now we can just copy these lines and paste it here. And now we will assign the serial number to the server. Those attributes I will call SN. Okay, this line will change completely. UA int 42 serial number. Okay, that will be our serial number. We have to change this. Serial number, and the type is in 32-bit. So now serial, note that it will be R1 TS1 serial number. The parent will stay the same. So we will change this to serial number as well. And here, instead of using the SN attributes, we can have the VN attributes. We'll use the SN attributes. Okay. And we will do this one more time. And now we will add the measure temperature to server. TP UA double, but because we don't have a sensor connected to my PC or to my VM, and I want to change the value later, I will define a global variable called temperature, and I will set it to 20 degrees. So I don't put this field here. So, and this, I will change the serial number to temperature. Sure. Okay. So, now I have changed the server. Let's try to compile it. For this, I will open up a new window here. Okay, and now let's start the server. And here I will open up a new window. And I will navigate it to my Python directory, because inside here I have created a little Python script which allows me to read out the server structure. So at first I will import from the OPC UA module the client, and from my module I will import everything inside it. Okay. So now let's create a client which will connect to our server. OPC TCP. And now let's connect to the server. Okay, now we are connected to the server. And as I already mentioned, there is a root node out there, and this root node has the ID 84, and there is an object node which is our mounting point at which we put all the nodes in. It's the ID 85. So So now I will create a variable called servers node, and what I'm doing now is not so important. I will just build me a list of all nodes inside the server. Node. Okay, this will take a little time because it searches all the namespace of the server for nodes. Node show, and I have written a method called show hierarchy, and this will show you the hierarchy of the server. So here is our mounting point, and here we have some server variables and server objects. For example, the local time, the namespace array, which contains all the namespaces available on the OPC UA server, and things like that. And down here we have our custom defined object temperature sensor, which has the vendor name, the serial number, and the temperature assigned to it. So let's try to read the vendor name. And every node, I have assigned every node a number here, and with this number I can access the value. Okay, yes, and the vendor name is Sensors King Limited. The serial number should be 1, 2, 3, 4, 5, 6, 7, 8, and the current temperature should be 0. Okay, maybe something went wrong here, but you've seen the concept. So now we have already filled in some data into our server, and I think that's a good ending for today. In the next video I will show you how to connect the temperature, for example, how to change the temperature in a sensor, for example, by reading out the temperature sensor, but we will make a little simulation with random values. But that's it for today. Thank you for watching, and I will see you in the next video.